Hi, it's good to be with you today for another lesson in our series on diversity, continuity and change. Today we're going to start off by answering this question. What is the most compelling evidence for evolution? By compelling, or most compelling, we mean what is the evidence that provides us with the most amount of argument that we could possibly offer to say evolution exists. In other words, there have been changes in the gene pool of populations over time. Well, the most compelling evidence lies in the presence and existence of fossils. Paleontology is the study of fossils. So if you're a paleontologist, it means you work with fossils in order to find out more about life forms that existed long ago but don't exist today. So we need to ask the obvious question then, what is a fossil? A fossil is a trace of a previously living organism which has been preserved in a substance, and most commonly that substance is stone or some form of mineral. The most common fossils are formed from body parts, hard body parts such as bones or shells, which, as we will learn next week, become mineralized and become not any longer bone or shell themselves, but become part of the stone or rock in which they are embedded. But fossils can also include the remains of activities of living things. Now, these fossils are far more rare. They are far more rare to find, but they're very, very interesting. We seem to find a lot more bone and shell fossils simply because bone and shell are hard substances. Other remains of organisms are much softer, and so it's far less common to find these soft substances that have been mineralized or preserved for many, many, many millions of years. You can find footprints that have been fossilized and imprints of leaves. You can even find burrows that worm-like animals made in mud, which have then become fossilized. A very interesting kind of fossil is a coprolite, which is animal dung that has become fossilized. So, although most commonly fossils are found in stone and in tree resin, which when it's fossilized is called amber, tar pits, ice, volcanic ash and peat swamps are also places where fossils can be found. So let's unpack some of these areas where fossils are found, because some of them may be less familiar to you. We've spoken about stone, fossils being embedded in rock, and as I said, next week we will look at how this actually takes place. But trees produce resin, which can trap insects or little parts of leaves, twigs, in the amber or in the resin, which then hardens and becomes amber under great pressure. And amber is as hard as a stone. It's a mineral that is very hard, and so we can see the organism preserved inside the amber. Tar pits and peat swamps are very similar, really. They are areas where there is a very low pH. It's a very acidic environment, a marshy environment, where the animal would need to fall into the tar pit or into the peat swamp, and the increased amount of bacterial activity that would occur outside the swamp that would break down an organism doesn't happen inside the peat swamp, and so you find whole organisms can be preserved inside these swamps. Volcanic ash is a very interesting way of preserving an organism. It's been found in cases where volcanoes have erupted, even fairly recently, like Pompeii and Herculaneum, that whole bodies of humans have become covered in this stone and converted into the stone and become a kind of fossil. And of course, animals have fallen into ice and their bodies have become preserved in the ice. So, some visual reminders for you. We have found many examples of mammals, such as mammoths, preserved in ice. Human bodies as well as animal bodies found preserved in peat swamps. We have got volcanic ash, which can preserve organisms. And these photographs show you very beautiful examples of whole insects preserved in resin or amber. And one of our most famous fossils of all, of course, coal, is a carbonized fossil. More about fossils after the break.